Good morning, everybody. You are going to be watching this video and doing your homework on your own. So first of all, answers for the homework last night, number 34. Answers should be close to about 0.83. Letter B is about 228 centimeters. Since Deshauna measured to the nearest centimeter, a prediction that rounds to that nearest centimeter would be appropriate. Letter C is 72 centimeters. Letter D is 166 centimeters. E is 138 centimeters and 114 centimeters. Number 35, 10 times 0.555 is 5.55 feet. Letter B, 10 times 0.555 times 0.555 again is approximately 3.08. We're not going to continue to keep it exact when we start getting into multiple decimal points. And letter C, if you continue to multiply by 0.555 5 times, you're going to get 0.527 feet. Number 36, A, the points intersect at the point 1, 1. The lines intersect at 1, 1. And B, the lines intersect at the point -1, 3. If you have questions about that assignment, please make sure that you let me know, and I will go over them tomorrow at the beginning of the hour. So yesterday, we came up with a graph with our predicted values for the height of the ball after 0 bounces, so our initial drop height. After 1 bounce, we came up with approximately 110. After 2 bounces, 60.5. After 3 bounces, 33. 4 is about 18. 5 is about 10. And 6 is about 5.5. So you're going to want your specific predicted bounces in that table that you've created. They should already be there from yesterday. And now we are going to watch just one video. That's a typo. We'll stop the video after each bounce. This is a better video than the one that we did yesterday. So these are going to give us better results, hopefully. That'll be a little bit closer to our predictions. So here is our video. To begin with, we have our first drop, and it's going to go all the way up, almost out of sight, but it is just barely at the very top right here. If we look at our predicted height, this is 100. If we could draw a line across and start doing some measurements, we're looking at about 105, 110. So we're just over 110 centimeters. So make sure you've got that recorded. After 1 bounce, it's now dropping from about 111 or so. Now it's going to bounce up and 10, 20, 30, 40, 50. This is 60 right here. You have 60 right here. You can see a little bit of a shadow underneath the ball. The bottom of the ball is right here. 60 centimeters is right here. So you're going to put down your prediction. Now we'll do the third bounce. And we'll back it up just a little bit. Try to get it at that very top point of the bounce, and 10, 20, 30. This is 35. And again, there's a little bit of a shadow, but 35 centimeters is right here. Going to our fourth bounce. Five, 10, 15, 20 is right here. If we come straight across from the 20, it's almost lining up exactly. Going to our fifth bounce. And we'll back it up a little bit, get that highest point. Here's 10, here's 15. So 10 coming straight across from 10, I would say is right about there. 15, it's about the center of the ball. And then our last bounce, and if this is 5, this is 10, 5, so now we have our actual bounces. We're going to go back and we're going to record those heights here. What I came up with was about, and I'm not getting a pen now, sorry. I'm getting about 111, 62, 35, 20, 12, 17, 7. So now that you have that data, we want you to compare that with the predicted heights and see how close we were. So compare your experimental data to your predictions using the table and the graph. What might cause your experimental data to be different from the predictions? Do you think that your table and graph model the situation appropriately? Why or why not? So this is question number 30 in your book. And then last, you're going to compare the graph for the two. You're going to use the same kind of an equation to model, or can you use the same kind of equation to model the two situations? What family of functions do you think would make the best fit for each data set? Remember, we talked about in the intro this being an exponential decay. So exponential and decay, there's your hint on how this might be a little bit different. Discuss that with anybody you can access in team or during class. And then describe how the pattern of growth for successive bounces is the same or different from other models that you've looked at. Okay. So you're going to be completing problems 30 and 31 today in class. When you are done with that, you can finish off day 2's homework, numbers 37, 38, and 39. Worst case scenario, talk to each other, help each other out. You can always email me, but my best guess would be, I would say, write your questions down and ask tomorrow if you can't get them figured out. Have a good day, everybody, and I will see you tomorrow.